Hello everyone. Today we're going to present our final project, which is world population analysis and predictive modeling. So, first of all, is brief introduction of the problem. The World Population Analyzer aims to provide an automated solution for collecting, analyzing, and visualizing global population data. It identifies key factors like urbanization, fertility, and migration, while forecasting population trends using machine learning. By uncovering insights and simplifying complex relationships through visualizations, it supports informed decision making in policy, economic planning, and sustainability efforts. Moving on is data descriptions and pre-processing steps. As you can see, these are the data descriptions. And data was extracted using beautiful soup, clean, and missing values were imputed. Features like population logarithm and urban to rural ratio were engineered. And numerical data was standardized with standard scalar, ensuring readiness for analysis and modeling. Okay, our third is insight discovered from the data. First of all is regional and demographic trends. High fertility nations like India and Pakistan are experiencing rapid growth driven by youthful demographics and high fertility rates. This contrasts with aging, low fertility countries like China, where populations declines pose challenge to labor markets and economic growth. Second is key drivers of population dynamics. Fertility rate has a strong negative correlation, which is minus 0.85, as you can see from here. And indicating younger population lead to higher fertility. Urbanization fosters denser populations as reflected in its positive correlation with density of 0.48, and the urban to rural ratio, which is 0.43. Migration plays a critical role in sustaining population growth in countries like the United States, where positive net migration offsets slowing natural growth rates. Third is strategic implication. High growth nations must invest in education, healthcare, and infrastructure to support youthful populations, while aging countries policies to address workforce challenges through migration and family support programs. Okay. Methodology details. The random forest regressor is used to predict the logarithmic transformation of population, leveraging its ability to handle nonlinear relationship and rank feature importance. Key predictors include yearly change, population density, and urban population, which are strongly associated with demographic trends. The model is trained with 100 decision trees using 80% of the dataset for training and 20% of the dataset for testing. Performance is evaluated with metrics like mean absolute error and R squared, while cross-validation ensures robustness and reliability, reducing overfitting risk. This approach effectively uncovers population dynamics and key influencing factors.
Now, next for the fourth part is the evaluation and results. Now, let's take a look at the mean absolute error of 0.088. It shows that on average, the model's prediction deviates from the true values by a small margin, indicating good accuracy. Also, the mean square error of 0.024 and 0.154 indicates the overall magnitude of errors, where lower values signify fewer larger errors. Also, the R square score of 0.979 means that the model explains 97.9% of the variability in the data, showing its strong predictive power. The scatter plot of actual versus predicted values show how most data points align closely with the diagonal red line, indicating that the model captures the relationship between predictors and the target variable effectively with few outliers. The feature importance of reveals the world share is by far the most influential variable in determining the target outcome, accounting for the majority of the model's predictive power. Now, the cross-validation scores ranging from negative 0.4 to negative 10.17. These scores indicate the model's performance on different subsets of data during cross-validation. The wide range, especially on the negative scores, suggests inconsistencies and points to potential issues such as overfitting or data imbalance. The negative cross-validation scores implicate that a potential need to investigate issues like outliers, imbalance, or inadequate data set splitting. Next are the conclusion and conclusions. So the purpose successfully analyzes global population, also adds insights for urban planning, resource allocation, and examine factors like fertility rates or urbanization. Now, the predictive modeling shows that this model shows a high accuracy evidence through metrics like R square or MAE. Also, the innovation integrates advanced data preprocessing, also visualization for scalable and dynamic analysis. It is also user-friendly, so it is easier to interpret. Identified limitations include cross-validation inconsistencies or potential overfitting. So, for future improvements, could address the issues such as enhanced resampling, also through outlier handling. So these are the contributions of each of our team members. And thank you for listening to our presentation.